Good afternoon. I am going to be working on problem 3 of the chapter 7. All right, so we have problem number 3. Okay, and here we're dealing with a problem that has to do with potential energy and kinetic energy. And just to start off, kinetic energy is half mv squared. Okay, so it's a function of velocity, and of course velocity will be maximized near the bottom. Okay, and then as velocity will start decreasing this way. So kinetic energy is then gonna be also greatest near the bottom because velocity is greatest. Potential energy is at maximum near the top since it has to do with heights. Okay, so the potential energy is maximum at the tops, and then kinetic energy is 0 over here. Kinetic energy is maximum at the bottom, and potential energy is basically not exactly 0 because there's 1 meter above the ground at the bottom of the track. So let's look at the questions. And then for part A, it looks like, what are we given on part A? Where on the track is the skater's kinetic energy greatest? Well, we just said it's at the bottom of the track. We just explained that. So for part A, K is maximum at bottom of the track. Okay, all right, and now we can move on to B. Let's see what B says. All right, B is asking for where does the skater have the most potential energy? Well, we just mentioned that also. Maximum potential energy is near the top. Okay, so max potential energy is near the top. Is not near, it's at the top of the track. Not near, it's at, okay? At the top points on the track. On the track. All right, so that is part B. And now part C. All right, let me get that. Let's see what C says. What is C asking? All right, no thermal energy is inherent total mechanical energy. The kinetic energy plus potential energy E equals K plus U. Choose the total energy graph on the bar graph as the skater is skating back and forth. Which statement best describes total energy? So if we go back over here, kinetic energy is 0 over here, and potential energy is maximum value. Kinetic energy is maximum value, and potential energy is not exactly 0 because there's a distance. There's a 1 meter distance, but the total kinetic energy down here, okay, it's the potential energy that was released minus that 1 meter difference. So there's still some potential energy at the bottom of the track. It's not 0. There's a small potential energy. And kinetic energy, even though it's maximum on the track, it can still go up more if the track were lowered. Okay, so the net between total potential energy and kinetic energy, you basically subtract them, and the total energy is always the same. It remains constant throughout the entire track. Okay, because as you go down, your kinetic energy rises, but potential decreases, and in the same proportions as it goes back up and down, and the total is always the same. So total energy remains constant. Okay. constant. All right. Now, for part D. For part D, okay, 1 second. So for part D, we are gonna be over here. Let's scroll down. All right. So let's see, what are we asking in part D? Okay, so what do we want to know? Okay, we want to order these. Place the skater on the track 7 meters above the ground. Okay, and look at the resulting motion and bar graph showing the energies. Okay, match the appropriate numerical values on the left with the energy categories on the right to complete the equation. Assume that the mass of the skater is 75 kilograms and that the acceleration of gravity is 9.8 meters per second squared, or Newton per kilograms. Okay. Oh my god. So we have, I'm sorry. So what were we given? 7 meters above the ground, and we were given a weight of 75 kilogram. Okay. So we have 75 kilogram times 0.8. And what was the other one? Times 7. So if we go to the calculator, this is the total energy, okay? Or the potential energy. This number represents the potential energy. Now, because there's a gap at the bottom of the track, the kinetic energy will not hit this value. It will hit some value that's close to this value, but smaller. So it's going to be like in 4,000. So, let me explain. So kinetic energy is half, or 0.5, mass, so, I'm sorry, 0.5 times mass, in this case is 75, right? Yeah, 75 kilograms. Okay. And tons, and okay. All right. And then the velocity is 9.8, right? Is that what it was? Times 9.8. Hold on. Okay, so, okay, I did this wrong. Wait, 9.8 squared. Sorry. So, and then we multiply that by the 37.5. Okay, so times 37.5. Now we're 36. Okay. So basically, my point here is that, I'm sorry, that can barely be seen, but the total energy is the 5,000 that we got on the calculator, okay? 5,145, okay? And there is a gap, so we're gonna take 5,145 divided by 7, okay? So we get per each meter. So if you do here, you got 735. So this 735 is the potential energy at the bottom of the track. And the kinetic energy at the bottom of the track is going to be the 5,000, hold on, 5,145. So 5,145 minus 735. I'm sorry that this thing is barely visible. Okay, 735. So 735, and now we enter. And the kinetic energy at the bottom of the track is 4410. Okay? So now, let's go back to the calculation. So total energy we'll calculate as 5145J, right? So this is part D. So, okay, so total energy. So total energy is 5145J, right? And kinetic at bottom is what? 5145 minus 735. Okay, and that equals, and we have the answer 4410. Okay, so it's gonna be 4410, and this guy is the answer to 735 is the potential energy at bottom of the track. So potential at bottom of the track at bottom of track is 735. Okay. All right. Let's see. Did I answer all the questions? Let me go through here real quick. So we got kinetic energy at bottom of track, potential at bottom of track, total energy at bottom of track. Well, total energy is constant no matter what. So total energy at top and bottom is always the same. Okay. And kinetic at initial is always 0. Okay. So we understand that. Okay. So since kinetic energy remains constant throughout the track, kinetic energy at the bottom is also 5K. Kinetic at bottom, okay, we just mentioned that, is also 5145 J. Okay, and then initial K equals 0 J. All right, so that is D. Now let's go to E. All right, here part E. All right, okay, we still had a couple left. Okay, so part E. Goodness, I'm so sorry. So the kinetic energy at the bottom of the graph is equal to the total energy? Is it equal to the amount of potential energy loss in going from the initial location to the bottom? Okay. So we want to look at the kinetic energy at the bottom. So yes, the kinetic energy is not 5,145 at the bottom of the track. It's 4,410. I forgot the J. So that means that it's smaller than the total energy. Okay, it's equal to the amount of the potential energy loss from initial location up to the bottom, right? And because to the bottom, but the bottom is not 0 meters, the bottom is 1 meter, so it doesn't go all the way. That's why this okay, that's why that's the answer, because it doesn't go all the way down to 0, so it's a little lower. Okay, so the answer will be potential energy from initial to bottom. Okay, so potential from initial to bottom. Initial to bottom. I'm sorry. All right, and then for F, we can proceed to F now. All right, what are we given here? Skater starts from 4 meters above the ground instead of 7. What's gonna go to that? Where's the 1 meter above the ground? So, okay. So if it started at 4 instead of 7, think about it this way. So if you start at 7, right? 7, but you have a meter. I'm sorry, this is blurry. So if you start at 7, right? You're actually not going down 7 meters. You're going down 6 meters. I'm sorry, I said minus 1. I'm sorry. So you're going down 6 meters, right? So 6 meters, all right? Okay, but over here on the problem, so the 44,110, right, is the kinetic energy at the bottom of the track when going down from 7 meters to 1 meter, which is a total of 6 meter height, going from the top to the bottom. But over here, instead of a 6 meter drop, what are we looking at? 4 meters above the ground instead of 7. So now we start at 4 meters instead of 7. So 4 meters minus the 1 meter is 3 meters. So we're doing a 3 meter dive instead of a 6 meter dive. Okay, so the total kinetic energy is half of this, because it's only 3 meters rather than 6. So 4410 is pretty simple. We just divide it by 2. We just divide it by 2, and that's the answer. And we get 2205. And that is what it says here. 2205. So that is the answer. 2205 J. And then part H. Or part G, I mean. Wait, how many parts do we have? Part G, yeah, I'm sorry. Not part H. So we have G over here. And then for part G, we're looking at 7 meters. What is the speed? Okay, so this is another problem that we're going to have to figure out how to do. So basically, you have 44, 110, right? This is pretty simple. So for this one, you have 44, 110, 44, 10J. You multiply by 2, okay? And you just, then you take that value and you divide it by 75, okay? The reason you multiply by 2 is because of the equation of half mv squared. You flip it over and it's the square root of 2 times the mass, okay? So over here, you're given that the, in problem G, the problem, okay, centimeters above the ground. All right, at the bottom of the track. And, okay, 75 kilogram. So, okay, so following this equation again. So you divide this and you get a value. You take the square root of that value, okay? So we're gonna do that. So we have 40, I'm sorry, I'm gonna try to get my calculator here. I'm trying to, so you have 4410 times 2 divided by 75, and you get 117.6. You take the square root of that, 117.6, and you get 10.8. So the answer is 10.8. So this is 117.6, sorry, 117.6, and then this is 10.8, which you can round it to 11 meters per second, and that's the answer. And then for part JH, so the speed is high. Okay, so here's how the speed of skater at the bottom compare down when the state starts 4 meters above the ground. So the speed is not exactly going to be double, even though the height is doubled, okay? So 4 meters above the ground means that there's a 3 meter dive versus 7 minus 1, that's a 6 meter dive. So it's double the dive, but the speed is not going to be double. It's going to be faster, but it's not going to be twice that fast, okay? So it's that one, okay? So for H, faster, less than twice, or less than double, right? Okay, okay. And finally I, which is the last question on our exam here. We have to rank these from least to greatest, the kinetic energy of the skater at the 5 positions, okay? Kinetic energy, hold on. The kinetic energy of the skater at the 5 positions shown from least to greatest. So obviously, potential energy from least to greatest, that's pretty simple. These potential energies here, okay, because potential energy is greatest at the bottom. So at the lower you go in height, the higher the potential energy. So the highest points are the lowest. So points 1 and 3 are lowest. Then we go 2 and 5 and then 4. And if we go to the answer, that's exactly what we should have over here. Yeah, 1, 3, 2, 5, and 4. So that is, so 1, 3, 2, 5, and 4, okay? And that is the end, okay? That is the end of this test.